Okay, uh, let's start. Okay, and so far, I think what we have seen is we have seen about initially the data types, right? And then we saw about operators and the various statements, right? Which is the things which are commonly used. Okay, so any questions you have so far? And I think we had one practical session also, right? When we tried about hello.java, fine, and what we did was we defined. Yeah, what did we define there in hello.java? Fine, a class, enum, enough interface, annotation, record. Okay, fine. So we understand Java is actually only about those 5 items. It's you define them. Of course, each one has their own various kinds of categories. Also, you can categorize them further. Okay, fine. So let's start with the class definition. So yeah, and what we understand is when we define any of these, we are actually defining a data type. Okay, fine. So let's start by defining our own data type. Okay, and we want to have a data type to represent a rectangle. Okay, we start and we take a simple example for having rectangle as a data type. Okay, fine. So if you want to have rectangle as a data type, okay, okay, I think I'll use this. Okay, so fine. So it's something like this, right? You got some rectangle. Fine. So there is an object to represent a rectangle. Let's assume this. Fine. So first we are starting with the assumption that there would be some object. Okay. Fine. Then first thing, what is it that you will think about a rectangle? Interacting. Let's decide the interactions first, maybe. Huh? Oh, so I should be able to. This is some object. So from that, I should be, if it's representing a rectangle, right, it should be able to give me the length. And I should be able to ask, oh, what's your length? I should be able to ask, what's the width? What else? Let's just decide the interactions first. So, oh, so we have an interaction here. Maybe it's about getting the length. So maybe we have a method called length. Okay, and we may decide that okay, it should be giving us length will be what type? Integer. Okay, so we may have length to give us an integer. So that's one interaction. See, what we are deciding is what interactions we should be having, right? Yeah. So you can know, if given an object, you should be able to know the length. Given an object, you should be able to know the width. Okay. Again, type is integer. Now,
ideally, the type should be double.
yeah. Double, yes, if you want to have it in terms of floating point. Right? Okay. Fine. Yeah, we can keep appropriate type. Fine, what you feel comfortable. But fine. Let's in this case, let's go with the int type. Okay. Okay. So yeah, and someone was mentioning area. Okay. So we can have area. So we are deciding what interactions we would like to have, right? And that should also be an int. Yeah. Okay, so a rectangle should be able to give me these things. Yeah. Any other interaction you would like to have with the rectangle?
can actually have many other interactions.
Yeah.
It depends on the context where we are using it.
Okay.
Depending on the context.
Yeah. Fine. So for what purpose you are creating the rectangle, right? Okay. In this case, yes, let's say it's just a simple thing. Fine. Okay. The simple usages, right? So someone may even say, oh, like area, someone can even ask for perimeter, right? Okay. See, this is one thing, right? So when this is simply an object and you are interacting with it, right? So if you say area, yeah, you're saying, oh, what's your area? And you don't have to specify the length and width because a rectangle has its own length and width. Right. So in order to have this, right, what should be done with the rectangle so that it can answer these queries? Okay, fine. Let's see. Okay, let's see. So first thing, okay, if I want to define a class to represent this kind of a rectangle, right? What should I be having? How do we go about it? We'll use the keyword class. We'll have our name for the class, and we decided to call it as rectangle. Okay, fine. Okay, so yeah, what should it contain? Method like this. Okay, but in order to have this method to return a int value, length method to return an int value, I need to maintain a place for it, right? So if an object is being created, it should have place for two things, right? Length and width. Okay, it has a length and width, right? So these are going to be what we call as instance variables. Okay, so when you define a class, you are giving structure for the objects. First thing is, yes, you may be deciding to give the structure to the objects of the class. Oh, what kind of structure? Every object will have what? And so if I'm defining like this, I'm saying, oh, it has a int length. Yeah, so it's a variable, right? So I'm keeping one variable, fine, whose name is length. I'm also keeping another variable name called width. Fine. Then we need those methods. Okay, fine. Suppose let's start with the assumption that we have only this much in our class. Yeah, what are these two we have declared variables inside the body of a class definition. These variables, if they are declared like this, they are referred as instance variable. Okay, and they are referred as instance variables. And so both of these are nothing but instance variable for our class called rectangle. Purpose, okay, now let me say, okay, let me ask a question now here. How do I use the length and width? Right, we have said, oh, our class rectangle has got one member is length, another member is width. That is in our class definition. And how we might be using this class definition? So this is a data type for me. Okay, so if someone writes a main method, right, so or any part of the code, someone may like to test this class, how he will be testing? He'll say, okay, I need to so public static void main, and he says, oh, I have okay, Now, since length is a member of the class rectangle, you might think, oh, we should have something like rectangle dot length, right? Yeah, length is a member of the class rectangle. So do we have something like rectangle dot length? Is that an int value available to me? Yeah. We have a class rectangle and we are saying, oh, it has a member called length. When we start defining a class, fine, whatever we are putting in the class definition is on an assumption that there is one object. If there is an object of rectangle, it should be having a length and it should be having a width. There's nothing like a rectangle dot length. Okay, because length is defined inside a rectangle class doesn't make something like rectangle dot length kind of a thing available. Length is available if there is an object of rectangle. We call it as instance variable. The purpose is it's related to an instance. Fine. Every instance has its own copy of the instance variable. When we say instance, we are talking about object of a class. Okay, and so this is not valid. Okay, and it's never going to work like that. Okay, what is needed before I can talk about length and width? I must first have an object. Right? See, someone defines like this. That's it, right? Someone has only defined two things inside a class definition. Okay, so yeah, how will the usage begin then? In a main method, if someone wants to use it, and say, oh, yeah, we should first have some variable, maybe r1 comma r2. Right? Oh, it's a data type. That's one thing. The rectangle is a data type. That's one thing. Okay, so that is correct, right? You can always declare variables for a data type. So you can declare variable r1, r2 for a type called rectangle. Okay, and then before I can use any of such members here, I must first have an object. Okay, r1 equals, we know how to create object, no? Okay, currently you can think like this. Use the keyword new, right? And use the name of the class whose object you want to create. Right? So once you have r1 equals this, now you can use r1 dot length. Yes, r1 dot length is available. What happens when we use this new rectangle? When we say let's create a new rectangle, yeah, it creates an object, right? It is creating object. Creating object means allocate space for the instance variables. Creating the object is nothing but allocate the space for the instance variables. Oh, we got two instance variables. They are of type int, so it allocates space for int, allocate space for another int for the width. So one is for the length, other is for the width. So a new rectangle is nothing but allocation of a new space. Okay, and when it allocates a new space, if they are numeric types, they will be initialized to 0, and they'll get initialized to 0. Okay, so yeah, you'll get 0 and 0 here. Right? So if we write a code like that, yes, this is what's going to happen. Right? You can create another object, right? And then someone could be writing a code which says r1. So length can be referred by object and not by using the name of the class. Okay, it's not with the type name but with the object that you can use the members. And so length and width only if there is object. Okay, fine. So initial part, that was the this is a definition part, and then this, by defining this, a data type becomes available, and then we have a usage part. So if we have certain members, what are the various usages you can make, right? Then creating a data type, and then how we can use the data type, and that's decided by what you have in this definition. Okay, how you use that type is dependent on what you have here. Fine. Most of the things which goes in a class definition is about an object, and if there is an object of rectangle, I should have a length and I should have a width. There are things which are not related, which do not depend on object of the class. We'll soon come to that also. Right? So you do have such members where they are not about object of the class. Okay? Fine. But most of it that you write, yes, it's related to the object of the class. So one type of member is instance variable. I think the purpose is clear. So like I can have r1 dot length equal to something. I can say, okay, let me make it 7. Okay, I can similarly assign r1 dot width. Okay, and I can then also be having something like r2 equals new rectangle. Then we can have something like, oh, allocate another object. Yeah, so if we use this r equals new rectangle, each time we are saying new. So basically this is like first time we said this is a reference variable r1 referring to an object of the rectangle class. It had 0, 0 initially, and we said r1 dot length equal to 7. So from r1, whatever object is available, there we are setting the value as 7. Okay, fine. R2 is equal to new rectangle. What would happen? Right, simple. We have another reference variable r2. Fine. Type is rectangle. Yes, we are allocating an object of rectangle. It has its own separate copy of length and width. They would be 0, 0. And r2 should refer here. So new means allocate space for the instance variable. So when you define a class, you can declare instance variables. The purpose is they would be part of the object. Only when object is there, right? Without an object, you don't have them. Every object has its own copy of those variables. Okay? Fine, clear? And so purpose is clear, right? Instance variables. Okay. Next type of thing is, oh, we decided some interactions we should have, right? Okay. So yeah, you want to have, so normally, yes, we have not yet used the data encapsulation part, right? We'll look at that part a little later, right? But still understand, if we talk about data encapsulation, it would mean that we do not want someone to say r1 dot length to be able to access a, fine, you don't access the internal structure of a object. And you do not want to allow someone to change the internal structure of the object. Fine, and there are reasons for it, right? What is the reason? Someone might just say r1 dot length is equal to minus 100, something like that. Yeah, and then we'll say, oh, we have rectangle where area can be negative, or we have a rectangle with negative area. Right? So we don't want to end up in such situation. We don't want to create types which will be like that, right? Okay. Right. So for that reason, yes, we can, at this moment, we are not making that provision, but we have a mechanism. And when we talk of object-oriented programming, yeah, a language, object-oriented programming language should have a mechanism where it allows us to protect from such things. Okay, that yes, you shouldn't be someone directly accessing inside an object. So instance variables are part of the object. They are the data part, and it is not a good idea to have direct access to them. Fine. But always, yes, someone would like to interact and fetch their values. Okay, oh, what's the value of the length? And so for that reason, we'll add interaction. So if we want to define interactions for the object of a class, we use methods. Fine, methods are nothing but the interactions. Okay, so let's see what are the methods we can have. Okay, fine. I think I'll start writing the code. Okay, so we define in a separate Java file, we'll define a class called rectangle. Yeah. Okay, see now onwards, what we'll do is we'll follow the correct practice, that is one Java file for one class definition. Okay, and file name matching the class name. Okay. We'll do that.
So in that we will have like public class file name.
Yeah, we may. What is public? Yeah, we haven't yet checked on that. So once we look at package, yes, we will talk about the access specifiers. Okay. So then we can, yes, so not immediately public, but yes, we'll see when we need the public thing to happen. So at this moment, yes, we are keeping it simple. Okay, so we may be defining like this. We have a class called rectangle. Okay, and yeah, first thing, instance variables. Okay, and that's an instance variable. Okay, we can another one with fine. If these two members are there, okay, fine. Maybe we want to have a separate class, or for the time being, we can even still go ahead here itself. So we might define also, along with this, we may define a class called test rectangle. Okay, the idea is whatever we are defining, we would like to test it out. Okay, fine. We need an application. That's a data type. This is our class created for an application. Okay, application is the method main. And so that's a Java application. And here, yes, you might use the type. So, okay, we know if we have a data type, we can, how we can use it? Declare variables for the type, right? Okay, fine. Okay, another thing you should know here is, okay, unless a variable, now this is something about the Java compiler. Okay, we understand the type of variables. This is an instance variable. Okay, this one is an instance variable. This is a parameter variable. And what is this R1, R2? They appear inside a method, right? Inside some body. It's fine. Fine. Not the body of the class. Not this one, like we call them as local variables. Okay, so we have a local variable. Okay, as far as the local variables are concerned, fine, local variables do not have an initial value. Local variables are uninitialized. So if I just say R1 comma R2, it doesn't make R1 and R2 as null. Okay, fine. Now the compiler always does a check that you do not use a variable which is uninitialized. You must first initialize a variable before it can be used. Okay. Variable needs to be initialized before you can use it. So that check is, this is applicable to, so because local variables are not getting initialized on their own, fine, you must have an explicit assignment before I can use them. Okay, for example, someone says, oh, let me try, I haven't done anything like R1 equal to, fine, so someone says, oh, let me try system dot out dot print ln, and he says, okay, R1 is plus R1, maybe something like this. You know string concatenation works? Yeah. String conversion would take place. This one is a compilation error. Reason? Yeah, what could be the reason? Not initialized. Fine. So this would not be valid. Okay. So to make it valid, yes. So okay. Okay. So yeah, now we can have. So let's do the initialization. How do I do the initialization? So you want to create a new object, then say new object. Okay, fine. Currently, yes, let's look at, like, you want to create an object with just a new rectangle and the object gets created. Okay, fine. Or okay, let's see, R2 equals, oh, we can do like this also. It's an initialization still. So it's still a initialization. Okay. Okay. Uh, okay, let's try out first something like, let's print system.out.println, and let's do r1.length equal to plus r1.length. Okay. Here, why the expression the way we have written? It's just in the output we'll like to see what we are printing, and so I'm just repeating. So it's r1.length is what we are saying. Okay, and so this is as a string. And so we can see what we are doing, right? Okay. So we may save and compile this code. Okay. So let's save this. We have a folder for our source code, and let's save this as, yeah, we would like to call it as rectangle.java. Okay. Okay. Fine. So still, yes, we have two class definitions in one Java file. Okay. Later, yes, we might split it up. And when the time comes, yes, we'll do that. Okay. So let's compile and check the code. And the class here is rectangle.java. And the Java file is this, or it has compiled. Want to quickly test out what happens if we try compiling by removing the comment here. Fine. Okay, just quick. Fine. Variable R1 might not have been initialized. It's very clear. Okay. So this is applicable to the local variables. And on local variables, yes, they need initialization before they can be used. And whatever the type, here the type is rectangle, it could have been even an int type also. Okay, and so we are commenting it. Okay, fine. So yeah, let's compile and run this code. It's getting compiled, and then we're running it. Oh, it's not rectangle. It's a, where do we have the main?
Yeah.
Okay, R1 dot length is equal to 0. Yes, initialization is there for instance variables. Right? Instance variables, they get initialized similar to the array members, right? Array elements, when you allocate an array, depending on the type of the members, the initialization is taking place, right? Reference type initialized to null, fine. Numeric types initialized to 0, Boolean type initialized to false. Okay, fine. So this is what we have done, and R2 dot. Oh. So let's again, just like we are doing for R1, let's do it for R2. So will it compile? Yes. Fine. Okay. So no compilation error. Okay. Let's run the code and see what happens. It says, oh, null pointer exception. Yeah. See, before null pointer exception, it says java.lang. Okay. Fine. So that's something we have to know about. And okay, cannot read field length because, oh, instead of R2, I don't know, for some reason it's saying local 2. Okay, internally maybe it is allocating some different variable, and for that method, yes. So there's local variable 1, local variable 2, right? So it's just saying, okay, local 2 is null, right? So, and it gives us at which line number and which file. Oh, in the main, within the rectangle.java file at line 13. And it's a test rectangle. The class is test rectangle, whose method called main and the file in which I find this definition, this class has been defined, is nothing but your rectangle.java file, and it is at line 13 that you are trying to use a null object. R2 is not an object. Okay, fine. It is saying, oh, there's no object in R2, and you're saying, okay, give me the length of that object. And so that is not possible. Fine. So clear. So, right, so we can comment this out. Fine. So members of a, so if we have two members like this, yes, we may, just like we have used length, it should be possible to also use width. You may set the values. So yes, you can set the values. So one could be saying R1 dot length equal to 7. Fine. Someone could also say R1 dot width is equal to 5. So that's the usage part. Okay. There are some other usages of the type rectangle which we can use. Yeah. Okay. For that, maybe one of the things. Yeah, we didn't. Let's try this thing again. That time it was not initialized, but now it is initialized. Let's try this out. Okay. Achha, we have put it as the last statement. I think we need to do it earlier, because once it gets an error, right? We have an error currently? No. Achha, that we have commented anyway. Okay, fine. So it's okay. Let's run the code. Yeah. What does it say? R1 is, and then there is a string conversion for the object R1. And what is that string conversion? It's giving us the name of the class, then giving at the rate and some value in hexadecimal form. Okay, so by default, this is how the string conversion would take place for any object. For any object, the object is of some class, and the object is of some type rather. Okay, if the object is of some type, fine, the string conversion, default string conversion, is to use the name of the type at the rate, and there is some hexadecimal value which is related to this object only. That particular object has some property, okay, which it gets by default. It's actually called the hash code value of an object. Objects have a hash code value, okay, and it's converting into hexadecimal string, and yes, it's giving us the string conversion. So default string conversion happens like this. Okay, fine. We'll keep it. Fine. It's not a good string conversion. It's not what we would like to have, right? Okay, fine. We might like a better one, right? Something better than this. Okay, fine. So we keep this, fine. Yes, we'll then see, because the output of this is dependent on string conversion, depends on class definition. And we'll see how we can set the string conversion according to our choice. We'll do that also. But yeah, before that, now let's fine. So we understand what's the use of instance variables. Fine. If there are separate objects, they have their own copies. Okay. Let's add some more members to this. So one type of member is instance variables. Another member would be, okay, I want to have a mechanism to give me the length. Yeah, we can have a method like this called length. When we have a method called length, and what does it do? Return what? Int. Return int. The type should be int. Yes. Yeah. So what do I write? Yeah. Look at this method, right? What does this method say? Does it have any parameter variables? No. Do we have any local variables? No. And we are saying return. What do we return? Do we have any variables? Do we have any variables here? Right? You may feel like saying, okay, let's use length here. But where is length? Have I declared length? As far as this method is concerned, does it have length? It's an instance variable is for the class. Huh? Yeah, if I write like this, it's going to work for me. Okay, it's still going to work for me, but this is not the actual thing. Whenever we write see one thing, just like the length and width, they require some object, right? For using length, or we can't say rectangle dot length. Can we say rectangle dot length? You need to have object first, then those becomes available to me. Same way, we need to have object first, then I can use the interaction with the object. I interact with the object. So first, an object requirement is a must. So, okay, so maybe what we do initially is let's not have, okay, let's go with something like returning a 0 here. Okay, and let's go with this method so that it gets compiled, and then we'll see what exactly is happening. Fine. The point which I'm trying to make here is that yes, we will have something like saying r1 dot, okay, so you might say system dot out dot println, okay, r1 dot length, yeah, equal to plus r1 dot, yeah. See, there's a difference between the r1 dot length, that's a variable, right? And this is but nothing but what is returned by invoking the method length on an object. Okay, before I go for this, let me also show another one which is here. Let's try this. Fine. Rectangle dot length, a method in the rectangle class. So let's say rectangle dot length. Let's invoke the method. It's supposed to return a 0, and there's nothing. Okay, so yeah, let's compile this. What's the error? The error is using length on class name. Rectangle is a class name. Type. Okay, saying rectangle dot length. No, length cannot be used unless you have an object. Okay. Right. So we are now saying r1 dot length. So one thing is the method length which we are writing here is invoked on an object only. When it's invoked on an object, and that object is available to us. So yeah, we can write like this. and we can declare the variable of type rectangle. So whether it is done on R1 or R2 or any object of rectangle, right? Length is not usable without a rectangle object. I'm declaring that yes, the length is always used on a rectangle object, and the name of the variable is this. Okay, and now if I have got something like this, I can say this dot length. Length is with the object. The variable length is available if I have an object of rectangle. This here is the object on which the method is invoked. Okay, let's compile. Right? Okay. This actually is a keyword. Okay. In Java, this is nothing but a keyword. Okay. So if you want, you can declare for methods, you can declare the first parameter as a variable called this. This is nothing but a special keyword. So it's for our methods, it's like a special parameter name. It's a parameter name. Okay. And the type has to be the same as the type of the class. Right? What is the class name? Oh, that's a type. So this is like the first parameter received in any method. Okay. This parameter here is known as the receiving parameter. It's known as the receiving parameter. And it's the object which is the receiver of this method. Right? It's nothing but the object which is the receiver of this parameter. See, this method, how is it going to be used? R1.length. Fine. As far as, see, I have said, oh, I need to pass a parameter here, right? Look at the invocation. Have we done that? Have we done that? What have we done? Oh, we haven't passed a parameter here. Where's the parameter? Where's that rectangle received from? In this invocation, r1.length, where is my parameter for rectangle? You are giving the parameter not over here, but over here. You are putting it before the method name. So when you are saying r1.length, basically r1 goes as a parameter to the length method. It's received as a, okay. So whenever we write any method, these methods we understand it works only if I have an object. So that object on which you are invoking the method is actually a parameter called this. And it's not mandatory to mention that parameter. Right? It's not mandatory here, and it's not mandatory there also. Yeah, we can comment it out. Yeah, we can comment it. Okay. So yes, it's not mandatory to mention the this, but this is nothing but the first parameter. It's nothing but, because this method, we mentioned that, right? We can't say rectangle dot length. We have to use r1 dot length. Some object. That object is available to the method. It's available as this. And so clear? So yeah, that's an example of a, so this is a method, right? Okay. So method, yes, it's not mandatory to mention the first parameter, but that's the first parameter. In fact, okay, the option of mention, this was actually not available for mentioning also. From Java 10, they have allowed this. If you want to be more explicit about mentioning this as a receiving parameter, yes, you can mention. So receiving parameter is a special parameter. Name is this, and the type is the type of the class in which you are defining it. Okay, it's a class name. Fine, but this is the only as a first parameter. It has to be the first parameter. Currently, our method do not have a parameter. Okay, but available from Java 10. Yeah,
Like an invisible first parameter.
yeah. It was always there basically. It was always there. Java 10 said, okay, you want to explicitly make it visible to others, you can make it visible also.
In C++, it's the same first parameter.
Yeah. Python, self. You put explicitly there, self. The convention is to use self. But if there is a Java programmer and he wants to write a Python code, instead of saying self, let him use this. When he'll be familiar with that, it will become more compatible.
I remember reading this in C++ object model. So they know this in the C++ object model.
Okay. And, okay. So when I leave that, fine. This is comment, and it's in this comment itself. Fine. I'll put information. It's a receiving parameter. Okay. Method. Okay. So this is a receiving parameter. Okay. So just like we have length as a method, fine. So one thing here, again, another part was here again. I'll have to also mention another thing. Here is we cannot keep two of them. You may write length also. Okay. You may have written this length, right? Okay. I think I'll do it other way around first. Okay. This is also going to compile. Okay. If you write just a return length, that's going to compile. Okay. So when we use length, right, what compiler is doing is, compiler is coming across length here. It checks, do we have a parameter called length? No, there's no parameter. There's no local variable called length in this method. Fine. It should go as a compilation error. Okay. But before it gives a compilation error, it says, oh, I find there is a instance variable called length. So it actually corrects it to this dot length. You may write length, it gets corrected to this dot length. That is done by compiler for us. Okay, correct usage is to say this dot length. Fine. Okay, see why that this dot length is necessary. Just think. So maybe if we proceed and add a few more methods. Okay, so yeah, we might keep one more method for the width. And we see, you can find variable names is a separate list, method names is a separate list. So a variable name may match a method name, may match the class name. Each list is maintained separately. So yes, things have to, you can't have two variables with the same name, two instance variables with the same name. Okay, fine. Two methods with the same name can be there provided they have a different signature. Okay. Yeah. So we have this method called width, and it might be using this dot width. Okay, we don't need this one. And so let's write it the way we normally code. So normal practice is to use like this. Okay, a good practice is to say this dot width. Okay, many times you may be saying simply width. Okay, now let's go for a method which returns void. Okay, let's have a method called set dimensions. Right? If there is a rectangle object, it has some length and width, you want to update it. Right? Then you will be passing parameters. Okay, so you'll say, okay, int length. So I'm not mentioning the first parameter here called this. Okay, it's to be assumed it's there. Okay, so you may be writing like this. So now here, what do we do? Is equal to length. Does it make sense? Yeah. It should have been. Okay. It's always a good idea to make it known that, oh, I'm talking about the instance variable called length. See, that is valid. Length and width as a. Okay, let me also tell you one thing. This is going to compile. Okay, this code will compile. From compilation point of view, but it's not achieving anything. The length here would always mean the local variable length.
Not reaching the time.
Fine. It's not on the object. Fine. Okay. Fine. So you won't get a compilation error. Yes, length is a local variable. You are assigning length to length. Okay, fine. It will just discard that. Compiler will see that, oh, this is something which would be fine. It should be happening, right? Okay. So I think you understand why this is. What is this? The meaning of this is clear. Fine. And why we should prefer using this dot length and this dot width. So here I'll comment this one, okay, and use this one. Okay. So it's I kept the comment so that you understand. Right? You can remember, oh, that's also valid here. Okay. If something is not valid, yes, we'll put in the comment that it's not valid. And so we'll maintain comments like this in our code. Okay. And so we understand method now. Okay. If we have method with parameter, fine. Okay, hidden parameter this, and we have used this dot length. Okay. Okay, so yeah, the code would be complete if I use this dot length and also initialize this dot width is equal to width. Okay, so we have got method called length, we have a method called width without parameters, and they will be, and they are just returning the values from the object current. Fine. So they all see, all these methods, they need an object. Unless there is object, you don't use those methods. Okay, now yeah, so all this code would work, that's fine. Okay, You were interested in what? Defining the string conversion? And you would like to take charge of the string conversion? Recollect the method name? Yeah, toString. Okay. So if you want to define how string conversion takes place, you can do that by defining a method. Okay. Fine. Public string toString. And here you can return a string which will look better. So maybe you'll say, okay, rectangle colon plus this dot. Oh, here also that receiving parameter, if you want, you can mention. This is always there, right, in all these methods. So this dot length plus comma instead of comma, okay, plus, okay, and this dot width. Yeah, fine. Okay, let's see the string conversion now. When we have the string conversion, oh, we haven't done the set dimensions yet, right? We haven't used set dimensions. So instead of doing anything like this, okay, I should have been doing something like r1 dot set dimensions, okay, 7 comma 5. Okay, yeah. So that can replace both of these, right? Okay. But fine, that was working, but yes, we can still do this. Okay, then let's, oh, sorry. Let's compile. It's compiling. Then we have added a method called toString and it's compiling. Let's run the code. Okay, that's string conversion. Yes, it's working now. Then this is a better one. Okay. Yeah. Okay. Okay. And so far what we have done is given a structure to the objects of our class and defined a few interactions. Let's add a better interaction also. Yeah, because we earlier wanted area also, right? So let's have a int area. Okay, we're just adding another method, return this dot length multiplied by this dot width. Okay, so area can also be used, right? It's just to make our class slightly better. Okay, and adding some more methods to it. Okay, now we got something called okay, okay. Now suppose someone asks you in main method, right, or at any point of time, I want to know how many objects I have created of rectangle so far. Okay, before that, yeah, another thing. Yeah, here, right, we have used set dimensions, right? But we understand when the object has been created, the values were 0, 0. Length and width were 0 and 0, right? It would be a good idea if we could do something like this. Yeah. Right? When we allocate the object that time itself, can I make the initialization of the length and width, which by default is becoming 0, to what the user wants to decide it. The user of the class can decide how the initialization of length and width should take place. Allocation is happening when we use new, right? So when it is allocated, I would like it to be initialized to whatever I use as the first parameter for the length, and second parameter is used for the width. Okay, initialize them. So this can be done, fine. So this can be done if we have a constructor. So we have another kind of member. What members go in a class definition? Instance variables, methods, okay, and okay, maybe I'll add just before this. See, it doesn't matter in what order you put those members here. Okay, fine. Class is simply a definition. There's no flow like this. It's not a flow. Oh, it's made up of all these members. Okay. So we can have a definition which says like this: rectangle. So it's not having a return type. It doesn't have a return type, and therefore what I'm defining here is not a method. It's a constructor. We call this as a constructor. Okay. So we may have some. The first variable is length. Second variable is for the width. And yeah. Oh. We can use the set dimensions method. When I've said this dot set dimensions, set dimensions method works on object. I must specify the object. So current object. So this is what we call as a. So this is the next item, which is nothing but a. So another member which goes in a class definition is the constructor. Okay. Right. So what is constructor? Name has to match the class name and no return type. That is a must. If you put a return type, yes, we can have method name which matches the class name. It would be a method. Okay. So constructor is a special kind of a method. You can think of it as a special kind of a method which is used as soon as the object is allocated. It's not used later. You don't use it on any object. You use it on the object which is getting created. It's being created, and the invocation of this method is the first thing which has to be done on that object. And it can only be used as a first method in a session. Okay. So subsequently, no, this cannot be used on an object. So when we say new, give a class name, allocates the object, and invokes that method. It's a special method. Constructor is just a special method. It also has that receiving parameter. Then you want to keep a receiving parameter here? Yes. We have used this dot set dimensions, right? We have used this. Okay, so constructor is nothing but a special method and available for use with new. When we use the keyword new, yes, we'll have this. So now what do you think? I've written this code. Okay, we have got a constructor here, and I have written this code. Line 30 is there, line 31 is also there, and 31 is using that constructor. What do you think? Is it going to compile or not? Should this get compiled? or do you see some problem? And normally you won't find there is any problem here, but let's compile and see what happens. Okay. Aha. Hey, something which was working earlier has stopped working. Line 30. Oh, that was working earlier, but you added a member in the class definition and this stopped working. See, if you add something, it would just enable something, some more things, right, to start working. But this one is actually affecting what was working earlier. Okay. The reason here is every class definition, and every class has at least one constructor. You have a constructor. When we didn't put a constructor, the compiler added the constructor for us. Okay. When we didn't have a constructor, it finds, oh, this doesn't have a constructor. Okay, let me put a constructor which doesn't require a parameter. And so compiler is adding a constructor if you are not having a constructor of your own. Okay. And because it says, yes, as soon as I allocate an object, I will be doing something. And what is that something? Oh, that will be nothing but the constructor. So by default, that constructor is there. It's not doing anything. That's fine. Here, so default constructor, or we say no parameter constructor, it's there as soon as, so we have a no argument constructor, right? Fine, we have a no argument constructor which comes if you do not have a constructor of your own. We can add more constructors. We can have our own constructors. We can have more than one constructor. Okay, we can have more than one constructor. We call it as constructor overloading. Okay. Fine. So yeah, this is fine. It says what is required are two integers, but you are not passing any parameters. Right? Found no arguments, required two integers. In the error messages, yes, you should have patience and read them carefully, and you should be able to know what it is about.
The solution would be int r1 is equal to
No, not int r1. It says you need what is needed as two integers, but I didn't find any arguments at all. The invocation.
okay, in rectangle.
Yeah, the parameter list
Length.
says the two parameters required are two integers, right? It needs two integers because you haven't made a constructor available, right? So let's make a change here. Okay, what's the change? Oh, we'll go back and we'll say, yeah, it's a good idea that we shouldn't be allocating a rectangle without the parameters being mentioned. So, fine, let's comment this out. Fine. If you want to create a rectangle, you need to give it the length and width. So this is good. Okay. Why should someone be creating a rectangle without even mentioning what is the dimensions you want for that? Fine. So we would like to take inputs before we allocate a new object. Okay. So our class can have a instance variable. It can have method. It can have constructors. Okay. We can have overloading of method also, right? Okay. Let's do a quick overload on the method. Oh, we have this method already. So we might say, okay, let's have a set dimensions. So I will only specify the value of the side. Okay, to mean, okay, I want to have both the sides equal. So if I pass only one parameter, it should be, I want them to be used for length and width both. Okay, this is to be used for both length as well as width. So we can say, okay, this dot set dimensions. And so that's a case of method overloading. Okay, so we have two methods by the same name, but input parameters are different. Okay, so that's a case of method overloading. Same thing can be done with the constructor. Yeah. So what do we do here? Yeah. In case of a constructor here, okay, so when we have a constructor overloading, right, from a constructor, I can use the other constructor. I would like to invoke the other constructor. See, it's a special method, right? So when someone wants, see, now what we are doing by these two signatures, by just looking at the two signatures is, someone wants to say new and give only two integer values, that was working. He says, okay, you can give me also one integer value, and then also you should be able to create. So we are giving users of the class rectangle two options for creating object. One is by giving two integers, other is by giving only one integer. Okay, now in this constructor, what you might like to do? One is, yes, you may just call the set dimensions, but instead of doing something like set dimensions, I'm not sure, maybe this constructor here may be having some more additional work which is always needed whenever a new rectangle is created. So my interest is to invoke another constructor from this constructor. From the constructor here, I would like to invoke the other constructor. How should I be invoking the other constructor? From a constructor, how I call the other constructor? The other constructor is a special method. It's not an ordinary method. You can't be saying this dot and say, oh, rectangle is name of a method. It's not a method name in that sense. If someone wants to use it, he will be either saying new, or a special mechanism is provided. We use the keyword this here to invoke a constructor from within a constructor. It's used like invoking a method. Okay, it's a special method, right? So yes, we can say this with a set of parameters. Okay, fine. So invoking a constructor, another constructor from a constructor. Normally, yes, whenever we have a constructor overloading. Okay, so when we have constructor overloading, okay, so when we have constructor overloading, fine, in a constructor, yes, we can use this with a set of parameters. So this is used as if it's a method name. Okay, fine, it's used for using another constructor which is existing in the class as if it's a method and just want to invoke it. Fine, used only when we have a, so when we overload constructor, yes, it's possible to call like this. And here, this with a set of parameters. Okay, now something about the special invocation of a constructor from a constructor. Whenever we want to invoke a constructor, yes, we are knowing we can use this, right? But if you use this in a constructor, it has to be used as the first statement of the constructor. You can't have any statement preceding the usage of this. So inside a constructor, the first thing you will do is, if you are interested in invoking another constructor, do that first. You can't have some other statement before saying this. Fine. You can't be saying some other statements. You can't have any statement before this inside a constructor. Right? If you are interested in using this, it should be the first statement. Okay. So if someone says, oh, let me try something like system out println, something like this over here. Maybe I just want to have a println like this, right? And let's try it. Call to this must be the first statement in constructor, right? Okay, and so we can't have here, right? Okay, so use of this is clear now. Two usages we have found, right? One is it's a receiving parameters in the methods and the constructors. Other is in a constructor we can use it for invoking another constructor. And this followed by a list of parameters. Okay, so what are the members which go in a class definition? So far, whatever we have seen. Yeah. Yeah. Okay. Methods. Constructors. And so far, what we have seen is this much. Okay. Let's proceed further then. Then clear? Examples are also clear? Instance variable example. And methods, constructors. Methods will define, but methods work only if there is a object. Okay, now, as talking about another thing is, someone wants to keep track of how many objects are getting created. At any point of time, right, can the rectangle class give me a mechanism by which anyone wants to know how many times the constructor of rectangle has been called? Each time you call a constructor, it means a new object is getting created. So someone says new, I should have a count getting incremented by 1. Calling new means calling a constructor. And someone says new rectangle, oh, it calls a constructor. He may be calling this constructor, the constructor, right? Fine, we have those two constructors. So maybe he's in the constructor, which is this one, or maybe in this one. Right? So we need a mechanism to keep a count, right? So yes, we will have some variable for count, right? And we can increment it in the constructor. So if I increment in the first constructor over here, okay, so maybe what I do here is I'll say, let's have the initialization here. Let's have count plus plus. Yeah, so count would be a variable, right? Okay. Yeah, so where do I have this count being declared? Where do I declare the count variable? Oh, it can't be in this constructor itself, right? It is a variable which should be made available to anyone. we need this variable to be such that even if there are no objects, the variable exists. In the main, you want to declare count in the main, then how will constructor be able to know about it? See, one thing, we want the rectangle to be able to manage. In this class definition, we want a mechanism to manage. So it's part of rectangle, not part of the test rectangle. And it has to be managed in the class rectangle only and not by the. We don't know how this class is going to be used. Right? The mechanism which we are talking about is related to the class rectangle, right? Okay, we want to talk about, oh, rectangle should be able to manage a count of its object. How many it has, how many times the constructor is called. So where do I declare it? If I declare it in the along with the length and width, then what would happen? Yeah, I want to increment count by 1, that's fine. But if I declare here count, what's the problem with this? It's an instance variable. So what happens? I'm interested in managing the count. What happens here? When I allocate a new rectangle, it will be allocating length, width, and count also. And they will be initialized as length and they were initially 0. Length and width from the parameter of the constructor, they get initialized. Count is incremented by 1, so it becomes 1. Then create another object. What happens? But that second object also keeps a count, and it says my count is 1. Every object will just say, oh, my count is 1, my count is 1. It can't be in the object. It cannot be part of the object. So anything which we have seen so far in this class definition was always about the object. We want to have something not related to the object of the class, not which is not related to object in the sense, not dependent on the object, whether object exists or not. I want something to be available. Fine. You use the method main without creating object of hello world. The keyword here is static. Static means, so as soon as you use the word static, you are not talking about the object any longer. In a class definition, everything was fine. Everything was, oh, only if object is there. Assumption is there is an object and this is then going to be available. But now we want to talk about something which exists even without the object, which can be used even without the object. Main method was used without creating the object of hello world. We declared it static. So just declare a variable as static. We call it as a class variable. Okay, it's known as a class variable. Okay, usage part, how do we use it then? So outside the class, how will I be using it? They are not associated with an object. They don't need an object. Whether object exists or not, this will exist. And that's how it is like this. And we won't put an object, but we would put a class name. Okay. and they are available as class name dot static member name. Oh, we don't want to be use, just like we do not like to use length and width directly. They are data variables. Same way, we may not be interested in using the static variable directly, but instead provide a method. Okay, and maybe we might like to provide a method which returns in name of the method. Okay, count. And yeah, is there some problem in this method? Where is count? In this method, is that do we have a count here? Yeah. Do we have a count as a variable? No, there's no variable called count in the method. There's no local variable. There's no parameter variable. It goes back and sees, oh, there is a count which is there. So it will replace it as. It's just like saying return rectangle.count. Yeah. Okay. Fine. Now, from usage point of view, so this is going to work, this is going to compile, and this is going to be working. How will I use this method count? I must have an object. It requires that object should be there. Otherwise, count cannot be used. Just like area and fine. Okay, but you would like to use count without even an object being available. You may not have created an object and would like to be able to use count. So what is to be done? No object required, right? Static means object not required. Okay, meaning of static is object not required. Fine. Do not in any way associate with the static variable in C or C++. That static is completely different concept. Yeah. And so this is a static method, or we can say class method. Okay. So what are the members which go in a class definition now? We have two more categories. Yeah. Fourth thing. Fifth one. And still there are more members. Okay. Now let's say I have this static method called count. Fine. Okay. Let's try out some other static method, maybe. Return void test static. Some method test static and parameters. Maybe I don't have any parameter here. Okay. And this one says, let's have system.out.println. Yeah. We want to print the length and width. Okay. So yeah, how do I access length? Or anyway, automatically it would make the changes. Yeah, you want to use this dot length? Okay, length should be used as this dot length because it's instance variable. Okay, that's right, this dot length. Okay, yeah, what do you think? See, what's the difference between the static and the non-static? This is a static method which we are writing, right? What's the difference between static and non-static?
Object not needed.
This is the difference between static and non-static. Static does not have this. Okay. And the keyword this, that is the difference between static and non-static. We don't have an object. So we can't be saying length or this dot length. We don't have this, the receiving parameter not available for static method. The receiving parameter is not there for a static method. They are not invoked on objects. They are invoked straight away by using class name. No object required. Fine. Okay. Okay. Right. And the keyword this. So as soon as you use the keyword static, forget this. Okay. In fact, like the entire class definition, we got a variable called this available to us. Only the portion which uses static doesn't have this. Everywhere else, this is there. Okay. For example, now this is only, and we don't normally do something like this, but I'll tell you something like, okay, I could be having in an instance in a class definition, I could be saying, okay, let me declare a variable of type rectangle. Okay, let me give the variable name as self equal to this, and that's still fine. Okay. This is available to me. The keyword this, and that's an object, because entire definition is, oh, if we have an object of rectangle. Static is saying, no, don't talk about the rectangle object now, not about the object. And static changes the whole context. And object context is gone. No objects. Don't talk about object of the rectangle class here. And you don't have the object available. Everywhere else, it's an object which is assumed. The entire definition is based on an object of that class being available. If the object is there, yes, then we can have length, then we can have width, then we can invoke length method, then we can invoke width method. Static, this is going to work without objects. Right? So when we declare static, it's like a global thing, not linked to the, we call it as almost, we can say it's a global variable. Static variable is global variable, except for, yes, of course, we do have encapsulation part. So we can reduce the accessibility, who can use it, who cannot be used, where it cannot be used, but there's only one copy. Okay, I'll show you something more here. Okay, this is related to the object creation part. Okay, Right? We visualized the object creation earlier. Okay, let's now have another look at it, because one more aspect has been added, which is about a class definition. Fine. We saw length and width are part of object. Okay, fine. But whenever, where is this variable called count? Where is it getting allocation? What's the space allocated for it? And when? Length width, we know about it, right? When is length and width allocated? By using new. Someone says new, oh, we allocate length and width. Life of the instance variable start when the object gets created. First step, okay, we have zeros. Then, oh, we have the constructor. Fine, the constructor may change the values. Okay, so that's my initialization part for length and width. Okay, what about count? Where is the allocation? And when? When is it getting allocated? It will have an initial value of 0. Let me tell you. Our static variable is having a initialization of initial value as 0. But one thing, before any class, the class rectangle is getting used in a main method. Rectangle is some definition. You compile, a class file got created for it. Someone wrote an application and says, okay, I want to use the rectangle class. He declares a variable, R1, R2. Nothing happens. It's just a compile time thing. There is no action required at the runtime. At runtime, okay, there's only 2 references, but nothing related to rectangle happens. But the first usage, other than just a declaration kind of a thing, any usage of the rectangle class. What is the usage of a rectangle class? Calling a constructor or calling any static method. That would initiate the loading of the class definition. Rectangle class would then be referred. It needs to load that and keep it in memory. This is the rectangle class definition. So there is a place where the rectangle class definition is going to be made available. It has to load from the rectangle.class file, and an object is getting allocated in the memory. There's a special kind of an object which here we say the class is getting loaded. The class loading takes place. When a class is loaded, there is some kind of an object which is created. Okay, this is the place where the entire definition is available. Okay, what is the definition? It says, okay, we have got 2 instance variables, type is int. All that information, whatever we have given in the entire class definition is here, and it's available through an object. Okay, this is the place where it keeps a space for all the static variables. So when the class is loaded, the static variable is getting allocated. The space for the static variable is here. It's not part of a rectangle object. Okay, when you say new rectangle, it will refer here and find out where is the constructor. I need to call that constructor, use that method. So the method the class definition is one object. There's an object. Okay, it would internally have sub objects. That's fine. Fine, they refer to further objects. But yes, there is one object, fine, which is getting created, which holds the class definition. Now, I'll not use the word class definition. It holds the type information about a data type. Fine. Okay, so static variable in a class is part of the class definition. The space where the class definition is loaded, same place, will have space for the static variable. So there is only one copy. See, this class definition won't be loaded repeatedly. It won't load each and every time now. It has loaded it once, and now this rectangle class is known to me. or whatever usage you are having. Yes, you want to create a new object of rectangle. Okay, I look into this. Oh, there are two instance variables, it's saying. So here is an object of rectangle with two instance variables. They would initially be 0. Okay, next what it does, it says, okay, when I allocate, that space has all zeros basically. Fine. And then if you have an assignment, right, you may have done like this: int length equal to 5, int width equal to 5. If you have made an assignment, understand it is actually making it part of a constructor. And the assignment which you mentioned here, it is building up a new constructor of its own, where it says, okay, I need an assignment of 5 to the length and 5 to the width. That would then happen. And then it says, oh, you've called a particular constructor to use that constructor code. Okay, fine. Okay, we have another kind of a member which can go in a class definition. Oh, I think, yeah, sorry, I think we'll continue tomorrow. Not tomorrow, on Monday.